Hello, and welcome to the third video in our series Vibration Diagnostics for Beginners. In this video, I will simply explain what kind of measurements you should take and what an acceleration sensor and a vibration meter or analyzer is. So, what is an acceleration sensor and how does it work? Imagine that your acceleration sensor is like a stethoscope which your doctor uses to listen to your heart. It is basically able to monitor the vibration signal from the machine and show you the values of these vibrations on your vibration meter or analyzer. The most commonly used acceleration sensor in industry is a piezoelectric acceleration sensor. It is an electronic device which in a very simple way looks like this inside, and like this in reality. A piezoelectric crystal generates an electric charge when it is deformed, meaning compressed or stretched. To ensure deformation of the piezoelectric crystal, you can see that there is some preloaded mass on it. The electric charge is transferred into the electronics of the sensor, where the electric charge is converted to voltage. This voltage is then transferred into your vibration meter through the sensor connector and cable. In other words, the sensor is shaking on the running machine. The preloaded mass is deforming the piezoelectric crystal, and this generates a voltage signal on the input of the sensor. A vibration meter or analyzer is an electronic device which is able to process vibration signals. If we think about it again in a very simple way, imagine that your vibration meter or analyzer is a voltmeter. The sensor is generating a voltage signal while it is shaking on the machine. This voltage signal is transferred through the cable to your vibration device. But your vibration device will not show you volts. It is smarter than that voltmeter. The vibration device is able to process the voltage signal and display vibration values such as acceleration and velocity. We will describe vibration values in our next video. The most common question about measurements is, what should I start to measure and what do these numbers tell me? Is it a good number or a bad number? What are acceptable vibration values for my machine? What are the limit vibration values which my machine should not exceed? Let's go back to low frequency and high frequency vibrations and talk a bit about vibration limits. There are some limit vibration values which can be considered as values indicating a worsening machine condition. We can set up the limits according to some experience with certain machines. There are also, for example, ADAS and ISO 10816 standards for those limit values. Or the ADAS DDS software can set up the limits automatically based on statistics from the previous measurements. All mechanical faults which are related to the speed of the machine, such as unbalance, misalignment and mechanical looseness, are considered to be low-frequency vibrations. These vibrations are measured as velocity in millimeters per second or inches per second. Maybe you are asking now how you can measure velocity with an acceleration sensor. With an acceleration sensor, you can measure an acceleration value, but the meter, the analyzer, can convert the value to the velocity value. The most common frequency range of this measurement is 10 to 1000 Hz. This frequency range is also applied on ISO 10816 standards. These standards take into account the size of the machine and its foundation. ADAS has defined vibration limit values which are related to the speed of the machine, not to the size of the machine. The frequency of 10 to 1000 Hz is also applied. You can download this ADAS vibration limit chart through the link below this video. Do not assume that a newly installed machine runs under its optimal condition. What if it was badly installed? It could be misaligned or unbalanced right from the beginning, as we described in Vibration Diagnostics for Beginners, Part 1. This way, we came to the conclusion that to monitor mechanical vibrations related to the shaft speed of the machine, we will use the measurement of overall velocity in millimeters per second, or IPS, in the range of 10 to 1000 Hz. This measurement is represented by one number. Using the ADAS-DDS software, we can trend this value in time and see its development. A specific part of the machine which we want to monitor is a bearing. Bearings, as well as gears, generate vibrations on higher frequencies due to their construction, their natural frequency. These vibrations are measured as acceleration in a G value. The frequency range of this measurement may vary a lot, and you should find out what would be the best for your particular bearing. But let's keep it simple and define your measurement of acceleration in the range of 500 to 16,000 Hz. ADAS has defined bearing vibration limits related to the speed of the machine again. The mentioned frequency range of 500 to 16,000 Hz has been applied. Even if we have ADAS bearing vibration limit values, they are just informational. These limit values were created on the basis of more than 30 years of experience of ADAS field engineers. Why do general bearing vibration limits not exist? As you can imagine, there are many thousands of bearing types on the market. Therefore, you cannot define general vibration limits. Also, you have to consider that each bearing on a particular machine runs under a different speed and a different load. Another aspect is how the bearing was installed in the machine. So, the second measurement, which we will include in our regular machinery measurement, will be overall acceleration in G, in the range of 500 to 16,000 Hz. It is represented by one number. Again, using DDS software, we can trend this value in time and see its development. The ADAS facet feature offers a very user-friendly approach to basic measurements. This type of measurement automatically measures in one step not only overall velocity and overall acceleration, but also the severity of individual machine faults, such as unbalance, misalignment, mechanical looseness, and bearing faults. All values are based on ADAS limits. So, for quick summarization, there are two important values which we should measure regularly on our machines. Overall velocity in millimeters per second, or inches per second, the lower frequency range, which indicates the general machine condition. Overall acceleration in G, the higher frequency range, which indicates the bearing condition. Maybe you're asking why we use different units, velocity and acceleration, for those measurements. Put simply, the acceleration is more sensitive to high-frequency vibrations, and the velocity is more sensitive to the lower frequency range. So it has become common to use those two units as they are the most effective for vibration diagnostics. Whether we use ISO or ADAS vibration limit values, they are just informational. You should always try to find out what the vibration limit values for your particular machine are. In other words, to find out what the optimal operational condition of your machine is. You can do that by measuring and comparing more machines of the same type, running at the same speed and under the same load, or you can ask a vibration diagnostician who should be able to make a deeper analysis of the machine and tell you if the machine is running under its optimal condition.